Okay, so we're going to continue with our study on quadratics. And in this case, we're going to look at the general form and the standard form. Now, the general form is this form here where f of x is equal to ax plus bx. Hold on a second. Okay, and the a does not equal 0. All right, again, just a distinction here. If a were 0, then it would not be a quadratic. So we make that distinction, a not equal to 0. Now we can get a lot of information from this general form if we know what we're looking for. Right? Now the first thing is this leading coefficient here. A is my leading coefficient, the coefficient of the x squared, the highest power here. Now if a is positive, right, I know that I'm going to have a parabola that is opening in the upward direction. Right? And if a is negative, right, then I know it'll open in the downward direction, right? In my plane, right here, I just wrote it outside of the plane just to have a visual here. Right, now, if we recall from our going over the graph, right, the axis of symmetry can actually be found by taking the values of making negative or negative whatever the value of b is, which itself may or may not be negative, all over 2a. Right, that would be the axis of symmetry. But as we saw that that line of the axis of symmetry always goes through the vertex, so to find the vertex, the x-coordinate would be negative b over 2a, and the y-coordinate would be the function value evaluated at negative b over 2a. All right, and so we can get that from general form just by using those, whatever those coefficients happen to be. Now, in terms of intercepts, if I wanted to find the y-intercept, right, well, in this case, we let x is equal to 0, and then find whatever is that. In terms of our general form, we see x shows up here, so our y-intercept would always be 0, since that's our x value, and whatever that constant c is at the end. Now, in terms of our x-intercept, okay, here we let y equals to 0, or f of x. So in this case, we're asked to solve a x squared plus bx plus c. Okay. All right, now in this case, we have a quadratic equation, right? And if it's set equals 0, I can always use the quadratic formula, right? So here, by now, hopefully you are familiar with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over plus or minus 2a. Right. Okay. All right, so now we can find the x-intercept as well by solving this problem. Now, as we saw from the graph, right, there's a possibility of getting 0 x-intercepts, 1 x-intercept, or 2. Right, now that all depends, if you notice on the layout of this, that all depends on what is under the square root. This plus minus indicates that there's a possibility of 2. Right? Now, there's a possibility of 2, again, depending on what this b squared minus 4ac is, right? Sometimes called the discriminant. If this is 0, well, there's no possibility of 2. We just really have 1 x-intercept, and that would be negative b over 2a, which again would be the vertex, right? That's the point. That's the instance where the vertex simply touches the x-intercept, right? Or the x-axis, I should say, and then either opens upward or downward from there. All right. Now the other option is this was negative, in which case we'll have the root of a negative, which is a complex number. So we have no real solutions, but we have two complex solutions, or sometimes called imaginary numbers. Right? But imaginary number is just part of the complex number. This would be the imaginary part if this was a negative in the root, and this would be the real part, and together they make a complex number. Now in that case, there's no real numbered solution, and we can see that in the graph, right? That it doesn't cross the x-axis, but there's still solutions to it, okay? In this case, they're complex solutions, so we don't see them in the real plane. So when this is negative, that corresponds to no x-intercepts in our xy plane. All right. Now, excuse me, when it's any other number that is in zero, any other positive number, I should say, the b squared minus 4ac, then we have two real solutions, and they'll show up as two x-intercepts on our graph. Okay. All right. Now, another form that we'll sometimes see is something called the standard form. And that has the form of this. All right, this A, so the standard form and the general form, they are related. So this A is the same A we see here. Right, the only difference is this HK. Standard form, sometimes called the vertex form, because if we have it in this form, the vertex is HK. All right. Easy enough, right? Watch out with those minus and pluses there. Make sure you get this correctly, right? So if you have minus 2, for instance, then the value here would be positive 2. But if, let's say, you had plus 2, the value here would be negative 2. All right. And for this k here, if it was plus 3, then it stays plus 3. If it's minus 3, then that would be minus 3. All right. So just keep that in mind. All right, now we don't have to do any extra kind of work to write it in the standard form, or any, I should say, work that isn't too involved, right? So what I mean is, let's say we had this function here, 3x squared minus 6x minus 9. All right, and then we wanted to write in standard form. Okay. All right. Well, I know that this h and k is the vertex, but I already know how to find the vertex, right? The vertex is negative b. So in this case, b is negative 6 all over 2 times a, oops, in this case being 3. So we get 6 over 6, which is 1. Now again, that's just the x component. Right. To find the y component, I'll plug in 1 here. 3 times 1 squared minus 6 times 1 minus 9. So that's 3 minus 6, negative 3, minus 9, negative 12. So my slope is 1, negative 12. Now in terms of rewriting this, right, a is the same a here. X minus h is 1 squared, and then my last one is minus 12, stays with the same sign. All right. Okay, now we have it in our standard form. Okay, so now we can go between both forms. Thank you.